So welcome everyone to our weekly workshop. All right, here's our schedule. Last week we talked about introductory networking challenges. So obviously we're on this several workshops that are covering capture the flag. And last week I talked about, I introduced networking challenges. This week, I'm just going to do a few more networking challenges because, last week I had enough time to talk about networking challenges, and I introduced Wireshark as a tool you can use and showed some of the features, and then I solved a couple of challenges. So today I'm just going to mostly be solving challenges using Wireshark, and I'll demonstrate at least one other tool that you can use to hack on networking challenges. And I'll talk about Wireshark packet filters. So this is the thing that I really want to get to in Wireshark. It's a pretty powerful way that you can filter packets in Wireshark. Generally, when you open up a PCAP file, you'll find hundreds or thousands of packets, and you get sort of lost in all the stuff going on. And so you can use some pretty interesting filters to get rid of a lot of that stuff. And so I'm going to talk about that a little bit today on the way to solving some stuff, and I'll demonstrate some packet filtering. And then next week, we're going to talk about web challenges. So we'll change the subject matter a little bit next time. Here's the CTF that we're going to use today. We're using this CTF for this whole series on capture the flag. And there's if you haven't used the CTF yet, you can just go to this link and you can self-register. If you've already got an account on the CTF, you're already self-registered, then you can just log in and we'll solve some of these together. As I've mentioned before, you're going to see some challenges added and removed to the CTF as I get to each one of the categories, because I want to use some certain challenges to demonstrate certain things. Okay, we talked about this last week, right? Last week. Networking challenges generally related to networking concepts, obviously. And you often are analyzing packet captures, not always. So today we're going to look at least one challenge where you're not analyzing packet captures, but you're still doing a networking thing. The tools that we use are listed here, and I talked about these last week. Wireshark is probably the primary tool that you'll use on networking challenges, although there's some other stuff, right? If you want to do things at the command line, rather than using the GUI Wireshark, you can use TCP dump or WinDump. Those are for Linux, Mac, and Windows. And then there's another tool called ngrep, network grep. So it's a way to search for strings in network packets. And I'll show that maybe today if I remember to pull it up at the right time. So that's a review from last week. If you want more details on this stuff, then you should go to our YouTube channel and look at last week's workshop. So today I want to talk a little bit about packet filters. And this is a way to clean up some of the stuff that you see in Wireshark, right? So last time we looked at the sort of main Wireshark user interface, and there's a piece of it that I did not talk about, and that's this filter bar that's right under the toolbar. And the filter bar lets you filter for specific components of network traffic. And here's a simple example, and as I talk through this example, I'm sure it'll make sense to the folks who have a little bit of networking experience. What you have to do is you have to create an expression here that is looking for specific things that you're looking for. And here, so this is a filter IP.dst. So that's looking for the destination IP address, right? So this filtering language is very specific. Fortunately, you don't have to learn very much of it to get a lot of use out of it. And so this, primarily you can use like things like IP.addr, which is IP address. Look for IP address. This one filters a little bit more. So you're not just looking for an IP address, which would show you that IP address either in the source or destination field. If you say IP.dst, then it's only going to show packets that have that specific IP address in the destination field, which is right here, right? So I say IP.dst double equals 10.3.0.20. That's going to show me only packets that have that IP destination address. And then this also uses a Boolean expression. So it says the filter says I have to match this IP address as the destination address, and it has to match the TCP.port has to equal 80. So TCP.port double equals 80. And so in that case, we're looking for HTTP traffic. And so you'll see the protocol here, HTTP, right? And each one of these packets either has a source or a destination port of 80. So that's a packet filter. And I'll show you how to use this in a minute. You'll notice that the color of the filter bar here is green, right? The background is green. What that tells you is that this is a syntactically correct filter, right? This is a legitimate filter. If I had put like ip.dest double equals 10.3.0.20, that's not a correct filter, right? You have to use the correct language here, and the correct language for searching on a destination IP address is ip.dst. And if I had spelled it wrong, if I spelled it dest, then the background here would be red. And what that means is that your filter is not syntactically correct, right? It doesn't necessarily mean that your filter is going to find anything or not. It's simply telling you whether it's a correct filter or not. And that's pretty useful, right? If you put in a filter and the filter bar's red, you're not going to see any results. Filter bar's red, well, that tells you, well, the reason I don't see any results, it's not because I'm not filtering for the right thing. It's because my filter is wrong. So I got to fix the filter until I get a green background, and then I can look down here and see if I found what I was looking for. So that can be useful. So basically, you just type in the filter. We're going to see this in a minute. You're going to get this kind of drop down. It's going to help you with the syntax to make sure that you put in the right thing by giving you some options. And then you can just hit enter, or you can click the arrow button. That's the apply button. It's also helpful to know that once you're done with that filter, then of course you can put in a new filter. But if you just want to get rid of the filter and not be filtering packets anymore, you just click on the X over here on the right side of the filter bar, and that's going to clear the filter. Now you'll see all the traffic. Okay, so that particular filter had a Boolean expression in it, and so it's pretty helpful to it's a useful filter to kind of explain it with. You can do some very specific filtering with Boolean expressions, and you can also use parentheses if you want to do your filters. So for Boolean expressions, you can use a logical and using the double ampersand. Or you can use and, uppercase and, instead of that. I usually use ampersands. And the logical symbol for or is the two pipe symbols here. So you can use the pipe symbols. You can use parentheses, as I mentioned, for more specific Boolean expressions. Wireshark generally doesn't care about case, except for when you're matching a specific string value. And I'll talk about matching string values in a minute. So, so here's some examples, right? If I want to show packets that are coming from 192.168.1.1, then I would put in this filter, ip.src, which is source IP address, double equals 192.168.1.1. If I want to see packets to and from port 80, then I put tcp.port double equals 80. That's going to show me packets that are going to or coming from port 80. If I want to see packets that are specifically going from 10.10.3.2 to 10.10.3.40, then I can say something like this. The IP source address of the packet equals 10.10.3.2 and IP destination address is 10.10.3.40, right? So I can be very specific in my filtering. And again, depending on the challenge that you're trying to solve, that can be very helpful. So any questions on packet filtering? Here's some common ports and protocols that you should focus on when you're solving networking CTF challenges. And some of this you're going to get from the description of the challenge itself, or from the title, maybe. So HTTP traffic is lots of HTTP traffic is generally in the clear. So TCP port 80 is what you might be looking for if you know that the traffic is going to be HTTP. FTP or TFTP traffic is port 20 and 21. So port 20 is the data port, port 21 is the control port, and we're going to look at some FTP traffic today. This is for file transfer, right? FTP is file transfer protocol. It's an old plain text file transfer protocol, not very widely used anymore, but you still see it sometimes. There's also a protocol called Telnet, which is used to get a terminal on a remote machine. Now we mostly use SSH for that. And the reason we use SSH is because Telnet is completely in the clear, right? So we looked at some Telnet, I think last week we looked at, maybe last week we looked at some Telnet traffic. That's TCP port 23. So if the challenge mentions Telnet, then you want to do TCP.port = 23. DNS is UDP and TCP port 53. That's domain name traffic. DNS is domain name system. So that's the tool that is used to match IP addresses to domain names. SMTP, Simple Mail Transfer Protocol, POP, and IMAP. Those are all mail protocols, email protocols. So these are the port numbers 25, 110, 143. And these are all in this traffic is all in the clear, right? If you're looking at this traffic, it's going to be plain text. Things that you can ignore or you can generally ignore in a CTF networking challenge are ports like 443, right? If somebody is, if you have a PCAP and it's got a whole bunch of port 443 traffic in it, that 443 traffic, it's all encrypted. So you can, most cases, you can just ignore it all. You can filter it out even. Same with SSH/SFTP over port 22. That's all going to be encrypted traffic. SMTP on port 465, secure IMAP on port 993, secure POP on port 995. That stuff's all secure. And so you're probably not going to get much out of it. So you can generally ignore all this encrypted traffic in a packet capture, focus on the stuff that's in plain text. That's where your flags are most likely to be, particularly in these sort of introductory challenges. Okay, so let's go to the Google's. I'm gonna go to backer.io/weekly workshop. So here's the CTF and log in. And I'm gonna hit some more challenges. And feel free to ask questions. These are still pretty introductory networking challenges. Again, once we go through the introductory version of all these different types of challenges, then we may look at some more advanced challenges across these different categories, but I want to focus on the easy stuff first. Okay, so networking, last week we looked at Ethernet to IP. This one here is very similar to that, so I'm going to leave that one for you guys to do on your own. We also looked last week at unsafe protocols, so we looked at some telnet traffic that was in the clear. Here's another unsafe protocols challenge that's very similar to this one, except for it's HTTP. Maybe I'll just click into this one really quick. Learn something about the wonders of insecure protocols. The answer is what's inside the curly braces. So folks may have already solved this challenge, right? I'm going to download the PCAP real quick, and let's look at it in Wireshark. Okay, there's a bunch of stuff going on here, right? A bunch of this is I don't know what it is. People trying to connect to a non-existent web server or something. Here's some real traffic, some real web traffic, and then there's a bunch of bad traffic again. So so it looks like there's a handful of different connections here, and I know I'm looking for HTTP traffic, right? So I might as well filter on that HTTP. So another thing I can do in my filter bar here is, unfortunately, I don't think I can zoom in this any. Another thing I can do in my filter bar is I can just put in protocol names in a lot of cases. And HTTP, I can just put in HTTP, and what I get back is HTTP traffic. And so this is several connections to a web page. And here's a GET request and a return, and a GET request and return, GET request and return. And this is interesting. Here's the flag, right? Password equals, here's the flag. Flag, I didn't know this would be this easy. Flag, and it says don't use HTTP ever seriously. And so this is in a, this flag is in the password field of the URL, right? So this is a URL option. And if I look at the traffic, there's this GET request, and it's sending a password option to the GET request. So this particular website that's connecting to must have a password field, and the way that the password field is passed when somebody types it in, it's passed right on the URL, right as part of the URL as an option. So if you have a URL, anytime you see a URL with a question mark and then something equals something else, that's a option. That's a URL option that's passed as part of the URL, and it's certainly a very insecure way that you might pass a password through to a web server. But that's this. This is a very simple CTF challenge. So there's the answer to the flag, and I'm going to show how to get this in a slightly different way. And this is simply to show off this tool called ngrep. Ngrep. So ngrep is network grep, right? So this essentially provides much of grep, much of the features of grep, but it applies them to network traffic. And so if you're familiar with grep, basically what you use grep for is you search for strings in files. With ngrep, you search for strings in packet captures, and so what you often see in a web CTF challenge is similar to this, right? You see flag, and then this %7b. This represents a curly brace, right? So you can't pass a curly brace on a URL in a URL, but what your web browser does is it turns that curly brace into the hex representation of a curly brace, which is 7b, and then that's the opening curly brace. The closing curly brace is %7d. But you often see flags of this format, right? Flag, curly brace, and then the flag, and then the closing curly brace. And so, knowing that, what I often do with either web challenges or network challenges is anytime you get a packet capture, one of the first things you might do is open up a Linux terminal and ngrep and look for the word flag, and then you pass in the simple http.pcap. You pass in the pcap file, and that's going to search that pcap. It's going to search the network stack for the word flag. And when I do that to this particular pcap file, I get back one packet. So here's the packet. It's from 127001, and this is the port number, source port number, going to target port number 127.0.0.1.8000. So this is this is a web server on localhost, right? So the person is hosting their own web server and then pointing to their own host. But what you see is the GET request, and then index.html, and then password equals flag. But here's where it found that word flag, and then here's the flag, right? Don't use HTTP seriously. And if I copy that, and I go back to my CTF, then that should give me my points. All right. So that one was pretty straightforward to solve. The Wireshark way was pretty easy, right? I just filtered on HTTP traffic, and it found what I was looking for really easily. Okay, here's another networking challenge. Morocco mole. Not sure where this challenge gets. Well, yeah, I sort of do know. So Secret Squirrel has a flag hidden in his DNS records. Can you find it? Secret Squirrel has a flag hidden in his DNS records. Can you find it? So, so if I didn't know anything about DNS, what I might do is search that DNS. DNS domain name system translates human readable domain names to machine readable IP addresses. Okay, so Amazon.com, for example, to an IP address. Okay, so DNS is that translation back and forth. Okay, so what's a DNS record? If somebody has something hidden in their DNS records, then what does that mean? So I might do some Googling around DNS records. And how do I find a DNS record? I could use whois to find DNS information. How do I check a DNS record of a domain? Okay, so here's a random website. I can use NSLookup dash type equals a host. Okay, and then the name of the domain. Okay, that's helpful. So Secret Squirrel, here's the domain, secretsquirrel.com has a flag hidden in his DNS records. Can you find it? And here's a way to look at what's in a DNS record. All right, so let's go to a terminal window and I will do that. NSLookup dash type equals a dash type equals a, and then the name of the secretsquirrel.com. Okay, NSF type equals a secretsquirrel.com, and I get back an IP address, and so I get back an IP address. Oh, this is the server IP address. Okay, and here's the IP address for secretsquirrel.com right here. So is this the flag? This is not the flag, right? But I might try that as the flag, and then I would learn that that's not the flag. Okay, so I've learned a little bit about DNS records. I didn't quite find the flag yet, but there's this type equals a, right? So if I look at man NSLookup, and then I look at that thing called type. Oh, is that not an NSLookup? Type. If I search on type. Okay. So there's different query types. There's different types of DNS records. And query type equals value, query type, it's not, could be a lot of information. But I did DNS record types. DNS record types. Okay, so DNS record types, there's the A type, that's the thing I just found, right? That gives me the IPv4 address for a domain. There's the quad A record. Quad A gives me the IPv6 address for that domain. Okay, so I might try that. There's this thing called a CNAME record, which is an alias. So sometimes a domain has a alias or another canonical name or another domain name that points to it. That might find me something. There's other stuff here, right? There's NS records. That's mail. That's the mail server. Or I'm sorry, MX is the mail server. NS is the authoritative domain server. There's this one called a, let's see it in here. MX. Oh, here we go, text. There's a thing called a text record, TXT. TXT stands for text. This record type lets the owner of a domain store text values in DNS. Several services use this record to verify ownership of a domain. So that's kind of interesting, right? I mean, I could try each one of these in turn. Take me a few minutes to go through and try each one of these different types. The one that seems interesting is a text record, because in a text record, I can store anything I want. And so for this thing, what I might do is I might go to type equals TXT. And here's what I get back. Right, it's a text record. It's text data hidden in domain in DNS records, and so this is stored on domain name servers, around the world now, based on this particular TXT record type in the domain name record store for secretsquirrel.com, and that's my flag. Looks like a flag, has the word flag in it, so I'm going to assume that's the flag. And so I'm going to submit that, and hopefully that gives me what I want. All right, 25 more points. Here's another PCAP. And it says dig-x 50.116.194.23. It says from the PCAP, not the interwebs. Okay, so a dig is another way to find domain name information, and a -x is a reverse domain lookup. So you can do a little bit of Googling and learn those two facts. But I just told you so you don't have to do it. And so what a reverse domain lookup does is it instead of finding the IP address of a domain name, it finds the domain name for an IP address. Okay, so this PCAP file must have some domain name information in it that will lead me to the domain name for this IP address. So I'm going to download this PCAP file and I'm going to open it in Wireshark. And I know that, so let's do some filtering, right? So let's say IP.adder equals 50.116.194.23. And okay, there's a bunch of stuff here. There's a bunch of traffic with that IP address. So can I filter and say, and UDP.port equals 53. Okay, so there's no DNS traffic back and forth between this. So I'm not looking for that IP address as a sender receiver. I think I'm just looking for UDP traffic. And there's a lot of UDP traffic. There's another filter I didn't show that might be helpful here. And it's this contains filter. So I can say UDP.port double equals 53 contains, then I can put in a string value 50.116.194.23. And that looks like it's not a valid filter. Okay, so here's what I did. I don't know if this is going to help me or not, but UDP.port double equals 53. So that's looking for DNS traffic. And UDP traffic contains, and I put in a string value, and the string value I put in was this IP address. And that gives me nothing. That's disappointing. Let's just do this. UDP.port equals 53. And it's going to be an easier way to find this. Oh, I searched on DNS already. Let's do this. DNS.a equals. So when I type when I put in something like DNS, what I get is in a dot. What I get is the possible things that I can add to that particular search, right? So there's all these different potential DNS things that I can search for. And so if I'm looking for an A record associated with this IP address, I can say DNS.a equals double equals 50.116.194.23. So that's filtering. That's using the Wireshark filter bar. DNS.a double equals then the IP address. And what I see here is I see query responses from a DNS server, and the A record is d.turn.com. So if I look down here, I can see the query and the answer. So this is the IP address that was returned on this DNS request, d.turn.com. So if I did a reverse lookup on this, I should get this. And so if I put in d.turn.com, I spelled it wrong. I get kicked back. d.turn.com. That should give me my points. Okay, 30 points. Okay, last challenge I'm going to look at very brief. Oh, I'm over time, so I'm not going to look at this. So these two challenges, you can apply some of those same concepts, right? Eve logs in. Here we have Eve logged into an FTP server. What's Eve's password? Okay, so you want to refer back to the slides and see what the ports are for TCP traffic. There's different ports for TCP data traffic and control traffic. So TCP data traffic is on port 20, TCP control traffic is on port 21. And I'll give you a hint here. If you're looking for somebody to authenticate with the FTP server, they're going to do that on the control port. So if you pull down this PCAP and do some searching on that information, then you're going to find Eve's password. And then for downloading a file, you're going to find the file download on the data port. And so you should easily be able to find the file that was downloaded by Eve in that network traffic and see the text that is the contents of a file. Okay, so I'm going to stop there because I'm at 32 minutes and see if I have any questions. Questions, comments? It's probably old hat to a lot of you. Okay, so next time we're going to talk about introductory web challenges, and thanks for being here. We'll see you next time.